All right, so today, last day of new material for the week. We're going to finish up equations of lines. We did parallel yesterday. Today we'll look at perpendicular. So if two lines are parallel, we just kind of did this in the warm-up. What are the two things that they have to have? Something's the same, something's different. And we already wrote this on the notes yesterday.
Let's just review.
Same slope. So that's the number with x, but they have to have different y-intercepts. What would happen if it was same slope, same intercept? Same line. It's the same lines. Two lines that are the same are not parallel. All right? So same slope, different intercept. Today, this is what's going to change. It's not going to be same slope. It's going to be different, and we practiced in the warm-up how it's going to be different. You got to do two things. And we're going to look at that. All right, so we did parallel. Now we're going to look at perpendicular. So parallel, we said those are lines that don't cross, right? They never meet. Does anyone know what perpendicular lines look like? Yeah, Mary?
So do they have max?
Like this? Like an X like this?
Like they cross. Wouldn't they cross like that?
Like that? I think they would cross like that.
Oh.
Someone else said something else I heard.
Like a 90 degree.
Yeah, if you want to be real specific about it, they cross exactly at a 90-degree angle. Actually, I have a picture right there. Just like that, like a plus sign. Right? Or like a capital T, right? The two parts of the T would be perpendicular. Right? And that little symbol, okay, in case you're not familiar, they use that in geometry. That symbol means that that's a 90-degree angle. It's also called a right angle. How many people had heard of that before, right angle? Yeah. All right.
But I think that next part mistake. I think the next part is talks about describing it. You guys pretty much already did that, right? They intersect, and where they intersect, what happens? Right, yeah. A right angle or a 90.
Yep. So where they cross, you actually get four right angles. 1, 2, 3, 4. The reasons why these are all right angles, that's something you might get into in geometry. Not really something we're going to get into here. But yep, you get all right angles. So perpendicular lines intersect to form right angles. And there's a special relationship between the slopes. The slopes can't be the same. Because if the slopes are the same, then that means the lines are what? Or if the slopes are the same, the lines could be
Same line.
parallel or the same line. So we're not looking for same slope today. They're going to be different, but they have to be different in a special way.
The criteria.
All right, so two things have to happen. All right, so when we're asked to write an equation of a line that passes through a given point and is perpendicular to a certain line, we did parallel yesterday. We're going to show you how to do it.
In terms of the next question, right? The form that we're going to plug that information into, right, or that formula, whether it's parallel, like we talked about, whether it's parallel or perpendicular, the formula you use is going to be exactly the same as what we used yesterday. The only piece that's going to be different is the slope. But in terms of that formula we want to use, that's going to be the same.
What was the name of that formula? Point what?
Slope.
Point slope. And then at the end, we usually change it to what? Which you're going to have to do on the test. Slope-intercept. So we start off with point slope. Okay, same formula you had yesterday. And then in the end, we usually change it to slope-intercept by doing the distributive and then moving something to the other side. All right, so we're going to go through the steps. I think there's just going to be one thing you have to add under the slope step.
You guys, we'll just go through these, and you guys can kind of just let us know what each part is. And when we get to the new part, we'll tell you guys what to add on your notes from yesterday.
So what happens with the y? Very first thing in the formula. What do we do with that? Yep. Stays the same.
Stays as y.
Yep. So you don't have to change that. Same step as yesterday. Leave the y alone. Next thing is the minus sign. We know we don't change that. How about y1? What do we have to do for that one?
Plug in parentheses or like a number for y for the set of coordinates given.
And which number in the coordinate is it? The first number or the second number?
The second number.
It's the second number, yep. So plug in the second number from the coordinate given. Same step as yesterday. No change there.
So then you can have your y, you have your y1, now you have your equal, right? This is going to be the new part, right? Because the next thing we get to is the what? What letter? M, right? And what does M stand for again? Slope. So this is what now, you guys might be able to tell us the two things. So we're asking, in this case, we're asking for perpendicular. So we've already talked about the two things that the slope has to be for it to be perpendicular. Does anybody know either of them?
Doesn't really matter which order you do it in.
Okay, which one you put first or second. It might be different in the way it's typed on the notes up there, but it doesn't matter.
Yep.
You find the reciprocal and then you make it the opposite.
Exactly. Those are the two things. I mean, here you find the reciprocal, which means flip it, and then make it the opposite. Doesn't matter which order you do them in. Right? I would just stick with the same order, and so you do it the same way, but doesn't matter. So the first thing you want to do is make it the opposite. Opposite means if it's positive, it becomes negative. If it's negative, it becomes positive. Just take the opposite. And then reciprocal is when you flip it. Now remember, you might not always have a number that's a fraction. If you don't, you can always put a what underneath it. Yusuf? A 1. Yeah, you can always put a 1 if you need to.
Guys, so now on your, like I said, on your notes from yesterday, you have the space on the M part. You have a 1 and a 2 that should be blank from yesterday. We didn't fill that in. So on the first blank, you write opposite, and put parentheses positive, negative. In the second blank, you'll put reciprocal, and that's your your fraction flipped. Is anybody not sure, guys, what to put down in your notes? Everybody not sure where we're putting that?
Okay. Other than that step, everything's the same. So all you got to remember is to do these two things to the slope, and that'll make it perpendicular. Next thing is x. What do we do with the x in the formula? It stays the same. That's the first thing right inside the parentheses. What comes right after the x? Could be a minus, could be a plus, it depends. But yeah, it's either a minus or a plus.
Opposite.
And then x1. What do we do to figure out that one? Yep, Ellie?
Plug in x from set of coordinates given.
Yeah. Plug in the x from the set of coordinates given. That's the same step as yesterday. So you don't need to write that again. Unless you don't have it.
The only thing that changes, guys, is that is the slope part.
All right, now, what are the two steps? Because now we're at the last part. We've got it in point slope form. We want to change it to slope-intercept. What are the two things you have to do? And these you have to do in a certain order.
Think about it now. You're gonna have parentheses.
We did it in the warm-up. Gigi?
Distribute.
Yep. So the first thing you have to do is distribute, which is always on the right-hand side. It's never on the left. And then there's one other thing you have to do. Donovan?
Get the y by itself.
Get the y by itself, which is going to involve either what or what. It's always going to be adding or subtracting. So get the y by itself, add or subtract. All right, so let's take a look at an example. Actually, you know what? We'll practice doing a few opposite reciprocals, and then we'll do an example.
So guys, there's no, as far as taking notes today, writing stuff like writing words and stuff down, that's done. Right, so the only thing you had to add to was your notes from yesterday. These are some examples that'll kind of be similar to what you're going to see on the take home.
Okay, so the first thing we're going to do, we're not even going to find the equation of a line. All we're going to do is practice finding a number and its opposite reciprocal. That's it. Right, so you don't have the numbers filled in. You'll have to fill it in as once Mr. Roy gives you that sheet. But the first number we're going to work with is 2/3. Can someone tell me the opposite of 2/3? Negative 2/3. Now, if we were trying to find a line that's perpendicular, is that the answer for the slope? Negative 2/3. No, it's halfway there. It's the opposite, but we didn't flip it yet. So now, take this number and flip it. And that's what goes in the last column. So what do you get when you flip negative 2/3? Negative 3/2. So we did two things. One, made it the opposite. Two, flip it. Got to do that every time. Okay, let's try this one. Negative 3/5. Bethany, what's the opposite of negative 3/5? We don't want to flip it yet. We just want to take the opposite. So you want it, the 3 is going to stay in the top and the 5 is going to stay in the
We're
bottom.
not flipping it yet.
So the 3 and the 5 aren't going to switch places. We just want to know the opposite of negative 3/5. Positive 3/5, yeah. So that's it. Positive 3/5. Now we want to flip it. So Catherine, what do I get for my final answer? 5/3. Yep. So that last column, we took the opposite and we flipped it. All right, Brady, how about 2? What's the opposite of 2?
Don't worry about flipping it yet. Just say, what's the opposite of positive 2? Yeah. Well, don't flip until we ask for the reciprocal. Don't get ahead of yourself.
Now I want to flip it. I want to take the negative 2 and flip it. Yep.
So we put a 1 under it now?
Yep, you can put a 1 under it.
So it'd be like negative.
Yes. Negative 1/2. So if we were going to find an equation of a line perpendicular, this is the first thing you have to do. You have to find this number, and that's your M. Okay.
You can do that first, or as you're going through your steps of your point slope and plugging into different things, you can wait till you get to that M step and do it then. It's up to you.
Okay, what's the opposite of 0? What is it? 0. 0 is its own opposite. Now that's not a fraction, so how could we make it a fraction? Because we got to get ready to flip it. Do what, Yusuf? We could put 0/1. What do you get when you flip that?
1/1.
Well, you got to have the same numbers you have right there. You can't get, you wouldn't have 1/1. 1/0.
Would it be 0 or 1, or would it still be 1? Yeah.
Well, what is 1/0?
0. Or, no, 1 would be
What's on top?
1.
1, right? It's a number.
So it'd be 1.
What's on the bottom? 0. A number divided by 0.
0.
What does that spell?
No. Just no.
No. So what does that mean?
You can't.
You can't do it. So when you can't do it, what do we write for that? We have a word that begins with a U. What is it? Undefined.
Oh, that's a rule.
That's a special case, all right? What kind of line is perfectly flat? Doesn't go up, it doesn't go down, it has a slope that's 0. It's a special-
The origin?
Horizontal.
Horizontal. So this is a special case. That's a horizontal line. What kind of line would be perpendicular to perfectly horizontal? Perfectly vertical. And we learned earlier, a couple weeks ago, the vertical lines have a slope that's undefined. Vertical lines are so steep it doesn't even have a number. It's undefined. So that's kind of a special case. Most of the ones are going to be like this. Okay. All right, so I'll do this one with you guys, and then I'll have it.
And then, yeah, maybe we'll try the next one, they can plug it in their own.
Okay. All right, so it says write an equation of a line that passes through that point and is perpendicular to that
So
line.
guys, on your notes, you have the parentheses, but they're blank. So you have to write in the coordinate, you have to write in the equation of the line. You have to write in -3, 1 in the parentheses that are there, and you have to write the equation of the line. Y equals 1/2 x plus 3.
Now, it's important they give me both of those things. Let's say they didn't give me this. They didn't tell me the point that it had to go through. They just said, find something perpendicular to that. Well, let's pretend that represents my line. That's perpendicular. That's perpendicular. So is that one. Any of these are perpendicular. But what's going to narrow this down to one answer is they said not only does it have to be perpendicular, it has to go through a certain spot. Okay? Only one of these lines is going to go through that certain spot. So let's see what the line is going to be. All right, let's write down our equation. Can someone remind me what's the? You don't have to give me numbers yet. Just what's the thing that I plug into? How does it start? Yeah.
Y.
Yep.
Minus.
And I'll come. Yeah, I'll come back. Oh, you want to go through it? Yeah. What is y1 then?
It'll be
What number?
1. Good. So y minus y1
equals
equals. What comes right after the equal sign?
x.
Slope. I'm going to come back to that. So I'm going to fill my slope in, but we have to find it in a second. What comes after the slope? X minus x1
So -3.
minus -3. All right, so a couple of things we can do there. On the left-hand side, is there anything I can do?
Remember, we're not putting in slope-intercept yet. We're going to, but not yet.
Yeah, that's what I'm saying, you can't do that after.
After, but how about right now?
No.
No, so we just leave that right now. And then I heard somebody say something about x minus -3. That becomes a +3. And now you have to put in your slope. What number you put there is determined by that word right there. If that word says parallel, you do something you learned yesterday. If that says perpendicular, you have to do something else. Looking at what's right here, what number am I going to use there to figure out my slope? I'm going to use the 1/2. Okay, the 3 doesn't matter. That's the y-intercept. All I care about is the slope, which is 1/2. Now, if it's parallel, I would just copy it down and keep it the same. Are they asking for parallel?
No, they're
No.
asking for perpendicular.
They're asking for perpendicular. So I have to take this and do 2 things to it. What are the 2 things I have to do?
Flip it.
So I'm going to flip it. So I'm just going to off to the side.
And you have to do the opposite.
I have to flip it. So I did the first step. And then, what did you say, Ellie?
You have to do the opposite of 2/1, so it would be -2/1.
-2/1. So that's my slope. Because they wanted perpendicular, I had to do 2 things. Flip it, and then take the opposite. So -2/1, or you could just put what's -2/1.
-2.
It's just -2. So that's your slope.
Ms. Hager, on this test, we're going to ask them to put it in slope-intercept, correct?
Yes.
Yes.
Yep. So if you get to this step, you get half credit. Okay, you got it to point slope. But now the directions are going to say right in slope-intercept. So what's the first thing I do to get that in slope-intercept? Yep.
Distribute.
Distribute what?
-2.
All right. And what is that going to give me, Garrett?
-2x.
All right.
And then do -2 times 3.
Then do -2 times 3, which is
-6.
-6. To this point, you're halfway in between. It's not point slope, it's not slope intercept, it's in the middle. We got to finish it and get it in slope intercept. So what's last thing I have to do? Yusef?
Plus 1.
Now we're going to do the plus 1. And what's negative 6 plus 1? Negative 5. And that's the answer in slope-intercept form. Okay. I'm going to draw a picture of that and show you the original, and we're going to see, do they look like a plus sign? If they do, then that means we did it right. Okay. Obviously, you don't have to check it because I'm not having you graph stuff on the calculator. But I think later in chapter 4,
Yes.
we use the graphing calculator.
That's your favorite section, mistake.
It's a graphing approach.
It is.
All right, let's type in the original. So we've got
Let's take a look at that.
0.5x plus 3, and now that's the original. Now what did we come up with? Negative 2x minus 5. 2x minus 5. Now when I hit graph, what should they look like if we did it right?
Perpendicular.
They should look perpendicular. Let's see. You got that one? We got that one. Do they look
Yes.
perpendicular? Yeah, they look pretty good. I think as long as I typed everything in right. Negative 2x minus 5 and 0.5x plus 3. Oh, you know why it looked a little off? I can tell you why. Tell me if it looks better now. Now this is going to be fresh looking now.
Guys, I told you.
I hit trig zoom because I'm used to doing that in my trig class. But how's that look?
That's fresh mistake.
Huh?
That's fresh.
Look at that.
You know what I'm saying?
Man.
So now you've got two lines. They make a plus sign. You got your 90-degree angle right there.
Oh, yeah.
So it's perfect.
You're a pro.
That's why they
He looks graphic.
Yeah.
He's good at it.
That's why they do.
All right, any questions on that? So that's it. That's all we're doing. Finding a line that's perpendicular to another line, and it had to pass through another point. Because if they didn't give me this point, I could have put the red line over here, or I could have put it over here, or over there. I could have put it anywhere. Anywhere. But they said the red line had to go through the point negative 3, 1. And I don't know if you can tell, but if you look carefully, it goes right through right there. That's negative, well, it's a little higher, but negative 3, and then up 1. It's right where I put it. All right. So, Mr. Ware, you want to have them try this one?
Yeah, negative. Guys, take a minute or so and just set it up. And if you're done setting it up before we start going over it, if you feel confident enough to go ahead and get it in the slope-intercept, do that too. Guy, get a seat for me. Yusuf, can you go back and sit? All right. First off, who's this guy up here? Anybody know?
No.
WWE.
Yeah, I just know. I saw him when you searched it.
Mean Gene Okerlund.
Oh, say that again?
Mean, that was his nickname. Mean
Oh, I thought you said
Gene Okerlund. Spell like this.
Hold yourself, please.
Okerlund. He was like a WWF, like he was on some of the shows and stuff, like he did the interviews like a reporter. That's Mean Gene. Maybe if we have time, we'll show you a Mean Gene video at the end of class. All right, so guys, I'm just gonna quickly, because most of you guys did this, I'm just gonna quickly set it up so you can see what it looks like. So you should add y minus 5 equals 1/3 x. That's what your point slope should have looked like. I know there was 2 negatives here because you had negative 3 as your x coordinate. 2 negatives in a row make it a positive. Some of you guys, what I saw, plugged in negative 1 for y1. That number right there, it's not important at all. It's just the y-intercept for the other equation of a line you're given. So don't get tricked. The only thing you need is the point, right? That's the point, and the slope. All right, the slope of negative 3. That's why it's point slope. Those are the only 2 things you need. The coordinate that it gives you, or the point, and then the slope in the equation that it gives you. All right? Then we're going to go ahead and again, that's at the, you're kind of in between now. You're not in point slope, you're not in slope intercept. All right? And it's distributed.
Oh, no, I get
And that is an equation of a line that goes through -3, 5, and is going to be perpendicular to the line of y equals -3x minus 1. Remember, don't get tricked. This y-intercept means that's not your y1. This is your y1. All you need is the point and the slope in the other line. That's all you need. And again, when I walked around and talked to some people, it might be helpful for you guys, those notes that we took today, actually the notes we took yesterday that we added to today, you may want to have them right next to you tonight or this afternoon as you're doing your take-home. And we can go through step by step. You guys, on the take-home tonight, you can use notes, you want to go online, whatever. All right? It's a take-home. We want you guys obviously to do well on it. Again, all the examples we've done in class are going to be very similar to what's going to be on the take-home. All right? So that's how we do that one. Now, let's take a look at this. If I gave you guys a coordinate, 0, -2, all right? That -2 is which coordinate? Think of the two letters that we have here. If I was to label this, the 0 would be the what?
X.
-2 would be the
Y.
y. Where would, if I drew a line, right? What axis would that with the line I drew? What axis would that line cross at? Right, we have a graph. On what axis would, if I had that point and I drew a line through that point, what axis on the graph or the coordinate grid would my line go through? But think about it. Which axis, which coordinate is the 2? Or the -2, I should say. The x or the y? The y. So at what coordinate, at what axis is my line going to go through on my graph? The y-axis, right? It kind of be right down here. All right? So like you guys said, it's going to cross at the y-axis. All right? So we've talked about this too, where the point that a line goes through the y-axis. What's another name for that we've talked about this year? The point where a line goes through the y-axis, where it crosses. Matt? The y-intercept, right? So again, if we gave you a coordinate like that, just know that that number, all right, whatever the number is, we talked about this a little bit when we did like functions and stuff like that. The number with 0 is the y-intercept. We talked a little bit about that a couple academic weeks ago. But the number with 0 is the y-intercept, right? Because what we're going to do in a second is we're going to need to remember that information. All right? So it's understand number with 0, that's going to be your y-intercept. All right? So now, on your notes, right, we got city council. You guys don't have to write this down. It's already written there. City council members of a small coastal town want to construct a new boardwalk along the beach. They want the boardwalk. This is the boardwalk. What's in bold? All right. They want it to be perpendicular to the road leading to the beach, which is the one that's a little bit lighter. Write an equation that represents the boardwalk. So now we're given two lines. All right. We're given a coordinate that's on both lines right here, and we're given one that's on the other. We want to put it in point slope form, and we want it to be perpendicular. Slope intercept, I'm sorry. We want it to be in slope intercept. All right?
I would find the slope of those 2 points.
Mm-hmm. Yeah.
Yeah.
So I'm gonna,
Yeah. And I would start with point slope form.
you want to use point slope?
You're gonna have to.
Okay. But we could, if we did the slope here, and we know our y-intercept of this line is going to be -4 because it's a 0.
They won't know that on one.
Yeah, we'll do the other one. We'll do the other one. Do you want to do the point slope? This one.
I would
This
do it the
one's
same
consistent.
way.
Okay.
Yeah, but it's up to you.
Okay, sure, we can do that. So we want to use this line. Well, like Mr. Hager said first thing we want to do is we're going to find the slope. Now you may be thinking, well, Mr. Roy, that doesn't make any sense because if we find the slope, we're finding the slope of this line. That's again, this is the road leading to the beach. We want the equation of the boardwalk. So why am I going to find the slope of the line that's leading of the road that's leading to the beach? Why would that be helpful to me? Because I'm not figuring out the equation of this line, the road to the beach. I'm finding out the one to the boardwalk. But why can I still find the slope of the road that goes to the beach? Why would that be helpful? Mary?
Because they're perpendicular to one another.
Okay, so tell me more.
So you could just find the slope and then do the opposite.
Exactly. That's why we're finding because we have enough information to find this slope. And like Mary just said, if we do that, we know that if I find that slope, if I make it the opposite reciprocal, I'm going to be able to have the slope of my road for the boardwalk. All right. So my two coordinates are 0, -4, and 5, 1. So let's call this 0. We'll call that x1. So if I'm going to call that x1, what am I going to call -4?
X2.
Careful.
Y1.
Yeah, that's going to be my y1. 5 would, Miguel, 5 is going to be what? What would I label 5? X2. And then, how about Alex? 1 is going to be y2. Talked about this a little bit yesterday. What's the formula to find slope? Slope only, not point slope, not slope-intercept. How about Natasha? What's the formula to find slope only? So you have like a little fraction bar, you get a minus here, you get a minus here. Do you remember? Somebody want to help out Natasha? Yeah. y2 minus y1, x2 minus x. All right? And again, I don't care the order you do them in, as long as you're consistent. If you're going to do y1 here, y2 here, you better make sure you're doing the same thing down here, as long as you're consistent. All right? So find the slope. So let's do that now. Someone tell me, based on how we labeled these, how about Dylan? Based on how I labeled this, right? y2, y1, I labeled my coordinates over here. Can you plug in the top numbers for me into that formula? I got them labeled over here.
I can't really see the graph.
I can't see them. Okay. Garrett.
1 minus -4.
1 minus -4. Good. 1 minus -4. And now, can you see now, Dylan?
Yeah, yes. It's too late now.
So now, let's go. You can do the x's now, since Mr. Hager zoomed in. All right. So we got x2 minus x1. So what numbers am I going to plug in?
5. No.
Yep, 5. Is 5 minus. Oh, Mr. Hager's really zooming in for you. He's trying to. All right, 5 is your x2. What about your x1?
What?
No,
What?
your x1.
Oh. Oh, yeah, okay. I kind of can't make that out.
0.
0. I couldn't make that out.
5 minus 0. All right. So now, when I simplify this, how about Chris? When I simplify this, what am I going to get?
You're going to get 1.
When I get 1, right? So on the top, again, this becomes a plus. So 4 plus 1 is 5. 5 minus 0, 5.
Indeed.
1. All right, so that's my slope. All right. Now, Mr. Hager said we're going to plug in. Again, we could get away with doing it the way I was thinking for this, but it won't work for the other one. So I want to make sure it's consistent for you guys. You can do it in both types of problems. All right, so now I'm going to use point slope. Someone remind me, what's point slope form? Y.
Minus 1,
Yeah.
equals m, parentheses, x minus x, close parentheses.
Perfect. All right. Paige, what am I starting with? If I'm going through my list, right, that we kind of filled in yesterday, and it tells me what things I have to plug in, what's the first thing I'm going to write? Y. How about Jacob? I just plugged in Y, right? What's the next thing I'm going to write? Before I even get to the Y1, what comes before that? I just plugged in
Negative.
negative. Good job. Next thing's going to be what, Bethany? -4, right? 'Cause that's how I labeled my Y1. Now it gets to the tricky part, right? My M. Why am I saying that M is tricky?
But isn't M slope?
Because you have to do the opposite.
Again, it wants these lines, right? It wants the road that leads to the beach and the boardwalk to be perpendicular. So like Mary just said, make it the opposite reciprocal. So what's our slope we just figured out? What number? Our slope is 1, right? Positive 1. So the slope I put in my formula has to be what?
Negative.
Negative.
Okay.
Negative what number, Donovan? 1. Because 1, if I flipped it, it's still going to be 1. It's 1 over 1, which is 1. After that, I'm going to put my what?
Parentheses.
Parentheses. Good. How about Melanie? After I put my parentheses, what am I going to put next?
X.
X, right? Does X stay as X?
Yes.
Good. X. And then Melanie said minus. What's the last thing I have to write? Someone tell me by raising their hand. What's the last thing I have to write? Gigi? 0, right? Because x1 is 0. All right? Anything I need to do before I start moving stuff around and doing stuff like that? Anything there we should do?
Make the y minus negative.
Yeah, the y minus -4. We'll make that a plus. All right, now I have it in slope. I have it in point slope. I want to put it in slope intercept. What do I do?
Would you do +1?
Nope.
Oh, would it be +4?
Nope. Remember, Gigi?
Distribute the
Let's
next
distribute first, right? What am I going to do? What am I? How about Joe? What am I distributing? -1, right? When I distribute, what do I get? Zero, right? I'll put +0. I want to keep the 0 positive. Y +4. How about the jelly? What am I going to do now after I distribute? Right? What do I have to make sure happens? Get y by itself. Very good. How do I do that? Subtract 4. Where else am I subtracting 4? On the right-hand side. Yep. From what number?
0.
Perfect. Very good. Y equals -1x minus 4. That's going to be the equation. Let me scroll up a little bit if it'll let me. That's the equation of my boardwalk. All right? That's the equation of the line for my boardwalk. All right? Look at my y-intercept. It says it's -4, right? Like we talked about before we did this problem. All right? My -4, right? That's when the line crosses, so I know I did that right. And my line is going down to the right. That means it's a negative slope. My number with my slope is negative. So I know I did it right. So again, that's how you're going to do those. Find slope. Plug it in the point slope. Again, so the only difference is here is you have to find the slope. Right? And the one we gave you before, the slope's there, you just have to identify it. Here you have to actually find it. All right? So what we'll do, guys, is I'll give you guys a little bit of time to do that next one. But I just want to go over just kind of what's going on for the next tomorrow and the next next academic week. So that example was example 4, guys.
Yeah.
Yes.
Okay, example 5. We'll come back to that. We'll have you guys work on that before you leave. All right. So. All right, so tonight, like we talked about, tonight's the take-home test. All right? Now I really want you guys to take a look at this, because I want to make sure there's no confusion or anything like this. Take-home test tonight. It's due at the beginning of class tomorrow. Now, for some reason, you may be out tomorrow. For some reason, you don't think you have enough time to finish it. You need to have a conversation with Mr. Hager or myself before the end of school today. All right? Don't take it upon yourself that when you get home tonight, oh, I got too much other stuff to do, I can't do this. You need to talk to one of us before the end. If you have questions, we'll answer them at the end when I'm done going over this. All right? But if you feel that you're not going to have enough time to do this, have a conversation with Mr. Hager or myself. All right? And we'll, again, depending on your situation, we'll let you know if you're going to get, we can give you extra time or not. Otherwise, it's due tomorrow at the beginning of class. All right? If you only did a couple problems and felt you would have more time, you felt you would have more time to finish, sorry. All right? You need to have it done tomorrow morning. When we check homework, we're going to collect the test. All right? So it needs to be done. All right? If it's not done for some reason, it's a 0, unless you talk to one of us before about extra time. But don't come in tomorrow morning and say, oh, I didn't have enough time to finish. You forgot to do it. Sorry, we're not going to give you extra time in that case. If you need to talk to Mr. Hager or myself about that type of thing before the end of the day today. All right? If it's not done, it's a 0. And guys, we did a take-home last year, and kids got 0s on it. Again, some of you guys may not have done so well on some of the tests so far this quarter. This is our last one. We want you to do well on this, so we'll kind of boost your grade up a little bit. So make sure you take the time to get it done. All right? If you're absent, all right, your test is going to be sent by email and send it to Mr. Hager. All right? Or if you need to send it to me, that's fine too, either way. Again, for some reason, you finish it after school and you want to turn it in then, don't do that. Either give it to myself or Mr. Hager. If you finish early and you want to turn it in before the end of the day, give it to myself directly or Mr. Hager directly. We've had people that have lost them in the past. We don't want that to happen. So give it to one of us directly. All right? So if you need more time with it, let one of us know. Otherwise, if you come in the morning tomorrow and it's on your desk not done, we're just going to take it, and it's going to be really easy for us to correct because we can just put a 0 in the book. But I don't want that to happen to anybody. Get it done. All right? Guys, just looking ahead. Oh, no, Mr. Hager. What happened?
Oh,
Yikes. Keep going down a little bit. There we go. All right. So, guys, tomorrow, after you turn in the your take-home, we're going to do an MCAS question until about 8:30. And then the second half, we're going to start preparing for the midterm. All right? Bring your Chromebook and bring any of the notes we've taken so far. All right, we're going to start doing a review for that. Next academic week, like we talked about, that's going to be your midterm week. You have midterms in all your classes next academic week. All right? Monday and Tuesday in here, we'll start reviewing for the midterm. So 13 days from now, that's when your next academic Wednesday, that's going to be when the midterm is. We're going to give you like a review packet tomorrow. That way it's going to kind of guide you guys a little bit in terms of what you need to put on the reference sheet. All right, the reference sheet will be similar to what we've done all year. It'll have examples for you guys to look up. But again, it's a lot of information. So I'm going to give you guys that review tomorrow. Then you guys can kind of narrow down what you need to put on your reference sheet. We're not going to force you to fill out the whole reference sheet. We're only going to want you guys to fill out the stuff on the reference sheet that you're not sure about. How are you going to figure that out? Based on the review packet we give you tomorrow. All right?